Today we are discussing about Coulomb's law in electrostatics. The law was proposed by Charles Augustin Coulomb. This is the inverse square law in electrostatics. Let two point charges Q1 and Q2, these are separated by a distance r. Then the electrostatic force of attraction between 2 point charges is directly proportional to the product of the magnitude of charges and inversely proportional to the square of distance between them. Vector r21 and vector r12 be the position vectors. F is proportional to Q1 into Q2 and F is proportional to 1 by r square. That is, F is proportional to Q1 Q2 divided by r square. We can write it as F is equal to K into Q1 into Q2 divided by r square. K is a constant that is equal to 1 by 4 pi epsilon 0. Epsilon 0 is the permittivity in free space that is equal to 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. Substitute all the values in 1 by 4 pi epsilon 0. We get 1 by 4 pi epsilon 0 is equal to 9 into 10 raised to 9 Newton meter square per coulomb square. Here we can clear that F is equal to 9 into 10 raised to 9 into Q1 Q2 divided by r square. Epsilon r is the relative permittivity and epsilon is the permittivity of medium. Then epsilon r is equal to epsilon divided by epsilon 0. F medium is equal to 1 by 4 pi epsilon 0 into epsilon r into Q1 Q2 divided by r square. That is, F medium is equal to F air divided by epsilon r. According to Coulomb's law, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. Put Q1 and Q2 is equal to 1 coulomb and r is equal to 1 meter. Then F is equal to 9 into 10 raised to 9 Newton. Now we can define 1 coulomb is defined as that charge which when placed in free space at a distance of 1 meter with an equal and similar charge will repel with a force of 9 into 10 raised to 9 Newton. The Coulomb's law in vector form. Consider 2 point charges Q1 and Q2. These are separated by the distance r. When the force is attractive, r21 and r12 be the corresponding position vectors. Then the force on Q1 due to Q2, F12 is equal to 1 by 4 pi epsilon 0 into Q1 Q2 divided by r square into r12 cap. r12 cap is the unit vector. Force on Q2 due to the charge Q1, F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square into r21 cap. If the force is repulsive, the force due to the charge Q1 and also the force due to the charge Q2, these are on the same direction and also the position vectors are in the same direction. Here we can write it as force on Q1 due to the charge Q2. F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square into R21 cap. Force on Q2 due to the charge Q1. F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square into R21 cap. The next portion is superposition principle. Consider a system of n stationary charges like Q1, Q2, Q3, etc. Qn in vacuum. Then Q1 is the middle charge, then other charges are surrounded by the Q1. Now, experimentally verified that the force on any charge due to a number of other charges is a vector sum of all the forces on that charge due to the other charges taken one at a time. The individual forces are unaffected due to the presence of other charges. This is termed as the principle of superposition. The total force acting on Q1 is the vector sum of the forces on Q1 due to individual charges. That is the total force F is equal to F1 plus F2 plus F3 plus etc. plus Fn. The force on Q1 due to the charge Q2 F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square into R21 cap. On the same way, force on Q1 due to the Q3 F13 is equal to 1 by 4 pi epsilon 0 into Q1 Q2 divided by R square into R13 cap. So the total force F1 on Q1 due to the two charges Q2 Q3 F1 is equal to F12 plus F13. That is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 into R12 cap plus Q1 Q3 divided by R13 into R13 cap. Then for all n charges F1 is equal to F12 plus F13 plus F14 plus etc. plus F1n. That implies F1 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 into R12 cap plus Q1 Q3 divided by R13 into R13 cap plus etc. plus Q1 divided by R1n into R1n cap. Simply we can write it as F1 is equal to Q1 divided by 4 pi epsilon 0 into summation over I is equal to 2 to n Qi divided by R1I into R1I cap. Superposition principle is used to find out the force on a charge due to more than two charges. Electric field. It is the space around an electric charge. where an electrostatic force is experienced by another charge. Let Q be the charge and P is the point. R is the distance between Q and P. Let a small test charge, small letter q, is placed at that point P. Then the force experienced by this test charge is given by F is equal to 1 by 4 pi epsilon 0 into capital letter Q into small letter q divided by R square into R cap. Therefore, the force experienced by the unit positive charge is equal to limit q tends to 0 F by Q is equal to 1 by 4 pi epsilon 0 Q divided by R square. The first figure is the isolated positive charge producing electric field, and the second figure is isolated negative charge producing electric field. Electric field intensity at a point is defined as the force experienced by unit positive charge placed at that point. Electric lines of force. It is defined as the path along which a unit positive charge would move if it is free to do so. Properties of electric field lines. Electric field line starts at a positive charge and end at negative charge. For an isolated single charge, electric field lines starts or end at infinity. This is an electric dipole producing electric field. In a charge-free region, electric field lines have no break or they are continuous. Two electric field lines never intersect each other. In a uniform electric field lines are parallel. The tangent drawn to the electric field line at a point gives the direction of the electric field at that point. Electric field lines do not form closed loops. The first figure is the electric field produced by an electric dipole, and the second figure is the electric field produced by two positive charges. Then, what is electric flux? Electric flux is defined as the total number of electric field lines passing normally through a surface. Look at the first figure. Phi is equal to Ea cos theta. Here phi is the electric flux and E is the electric field and A is the area of the plane. Then theta is the angle between A and E. From the second figure, phi is equal to integral E cos theta into dA. For small area dA, phi is equal to E cos theta dA. All over the surface, phi is equal to integral E cos theta into dA.